Hello guys there, you are very much welcome to this channel. In the last video we looked at was what happens when you write your code and it runs, what goes on behind the scenes, what goes on within the hardware, what is the contribution of the OS. And in that we looked at how the OS responds to our system calls. We looked at how it controls other devices using their device drivers. Now in this video, our main objective is to look at the RAM. Really, what does the RAM do, right? I understand we looked at it a little bit in the last video, but in this video I'm going to explain how the RAM is structured, the 5 segments of the RAM, and the importance of each. And I'll be using I'm going to be using still the assembly code, since it is the one closest to the hardware that will help us know how we put things into the RAM. You understand? Right. So the RAM is hardware. When you run your code, when you execute your code, you can double click that. If you're a programmer, you have written your code and then you run it after compiling it. When the moment you run your code, what the operating system does, be it Windows or Linux, it creates a virtual address space. I'll explain that concept later. It creates a virtual address space, it organizes the RAM and so on. It loads our code into the RAM depending on how we specified what is to be put where. And after that, it leaves control to our program to execute by our instructions, right? Now, meaning whatever we have written will at some time be in the RAM, but in which order? Now, if you look at a simple C code, let me try opening a file here. All right. When you look at a simple C code, just like that, like a simple C code of that kind, we have our main function here, and what we do normally, for example, if we want to, we can define integers, variables. Our variables, for example, we can say we are going to have an int x. We can say we are going to have an int y, but that one you're going to initialize it to 10. You understand? You can say now to print this out, you print, for example, you just write printf. Now if it is if it is an integer you want to print out to the standard output, use a specifier for an integer sending, and if you want to print out y, that's what you will do, right? You have initialized y to 10, you have not initialized y. Now how are these things put to the RAM, right? Now when you look at this assembly file, I have sections. I have the section.data, the section.bss, the section.text. For those who don't understand this, we are going to look at it right now, but this is pretty the same code I was looking at last time. And yeah, so let me first take you through the whole thing. The RAM has segments, right? Now the data segment when you run your code, what the OS does is it gets your initialized variables. Initialized variables, I mean, if we go back to our C code, you have this. You have initialized this. This is an initialized variable because you have initialized it to 10. Now, in our assembly code, when you compile this, it looks something of this kind. For example, I have this one, initialized variable. It's a double word, hello world. I have initialized this, right? Now, this is how it looks like. This is how it's going to be put onto the ROM, but of course in binary, not in human understandable format. Now that is the data segment. When we go on to the BSS segment, there is another segment called the BSS, and what that does is it's where the uninitialized variables are stored. For example, if we go back to our C code, we have said int x. We are going to use x somewhere, maybe in a for loop, maybe in a while loop, whatever, but we have not initialized it to anything, for example 0, for example anything. So that is stored in another segment in the ROM. For example, if you look at this, we have a section.bss and we have not initialized this. This is how I write an array in assembly. By the way, this assembly code is runs on Linux systems. It won't run on Windows. Don't try to run it on Windows. It runs on Linux. And the reason why it doesn't run on Windows is because of the operating system. Yes, the core, the CPU is the same. It's all Intel, which means the assembly will have the same instruction set, but the problem is with the variables, the data structures, and the system calls. You will make a system call one for write, for example 913 here, but when Windows understands something else. This is a Linux. I wanted us to follow. Those ones watch the other video to follow on with this. If you guys want me to program into the Windows system, you'll be putting that in the comments. By the way, don't forget to like, subscribe, and support. Big up. Okay, let's continue. The next segment is the text segment. Now, when you look at our C code, we have printf. Printf is a function. It prints something out to the standard output. Now, this one contains instructions. If it's assembled, it contains instructions to the CPU. By the way, when I say instructions, I mean, for example, if you go to this assembly file, this is our .text segment, and this is where we have our instructions. Move, 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 move. We are moving the system call number for write to the RAX register of the system, and we are providing arguments, what we want to write, what we're going to write, and the length of what we are going to write for those ones who know C code. These are the same arguments in their order for write, for the function write. And remember, and by making this call here, we're asking the kernel to do something. What the kernel is going to do, for those ones who watched the last video, remember, it's going to check what are these guys telling me to do. They're telling me to write. It will look at the number. It understands 1 as write. It understands the next argument is where to write. It understands 1 as the standard output. And it's going to check in the RSI for what we want to write. It's going to check for the length of what we want to write, and it will do that. And that's our text segment. It contains instructions to the CPU, direct instructions. The next segment is the heap. Now, for those ones who know skill, yeah, other languages have those kind of functions. Now, but in C, C++ maybe, we have functions like malloc, calloc. For these functions, you can dynamically allocate memory. For example, if you have an array, it's going to be dynamically changing. But you don't know its real size in real time as you're writing the code. What you do is you allocate memory in the malloc, but this is not just put anywhere, right? It's put in the heap segment. And I think for that, I've not the assembly code. Is it anywhere? But I know you understand what I mean. The next segment, the last segment, is the stack. Now, the stack is a continuously growing and shrinking. Both all of them, the heaps also can continue to grow and shrink. The stack, the stack also now, when a function is called within as as the code is running a given function, a function, for example, when you look at these instructions here in this assembly code, I can decide to put them within a single function. Let me try doing that. Let me try doing that. Let me try doing that here. I can say, for example, I can say that this I call this print. Now, by doing this, all of this code, from line 14 to line 18 are within the print function. And to make a call of that function, I just say call print. Yeah, that's how it's done. Now this is a function, and if you look at this function, it's making use of the variable that's the initialize variable this. Now when it's running, the variable will be saved in the stack and many other variables. Yeah. I think basically that's the RAM, the segments of the RAM, and yeah. Thank you guys for watching this video. I appreciate. Don't forget to subscribe. Don't forget to like the video. Put your comments. You can recommend me to do videos about anything. By the way, before I end, the reason I teach this, I was finding really a hard time. I won't lie. I started with Python. I was learning program, and of course, the first program, Print Hello World. Truly speaking, I never. Yes, Print Hello World is the easiest code ever, but I asked myself what goes on, what am I doing, right? And that's how I started digging and learning until. So for those guys, systems programmers, hackers, those are the guys who really need the low level programming, CPU intensive tasks. You need to understand assembly code, and if you guys want me to make more videos on that, put that in the comments. Otherwise, I think I'm going to end there.